From the 3Degrees Discussion Studio, I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
And we're running titanium, aluminum, vanadium, ELI in that machine. And that is a material that can be 3D printed and implanted in a patient. So if we look back at my career in 3D printing, I started in anatomic modeling, moved into surgical guides, and now this is kind of the next logical step to take this in providing care for patients using additive technology.
That was Amy Alexander. Amy is a unit head of Biomechanical Development and Applied Computational Engineering at the Mayo Clinic Division of Engineering. She joined the show today to share her journey in additive manufacturing and its impact on the medical sector. Before we get started, head over to www.3degreescompany.com and subscribe to the podcast. Remember, you can listen to the show anywhere you download your podcast, including Spotify, Apple, Amazon, or Stitcher. Also, if you or your company are looking for materials qualification or general additive manufacturing support, reach out to the team through our website or via email at info@3degreescompany.com. All right, Amy, great to have you on the show today. I'm excited for the conversation. Let's start where I like to start with everybody, way back at the beginning. So where were you born, where you grew up, kind of what were some of those early formative years like in terms of starting to get you down the path to where you are today?
Sure. So I was actually born in a military hospital in North Carolina called Fort Bragg. My parents were both in North Carolina at the time. My father was in the military. And so that's why I was born in a snowstorm in North Carolina in February. And soon after that, we moved to Minnesota. And I grew up in the Rochester, Minnesota area. And for most of my life, Mayo Clinic was my primary care provider. And I started showing some strengths in math at a younger age, and I always enjoyed math, which told my mother that I enjoyed problem solving. Both of my maternal grandfathers were engineers, and so I kind of grew up watching them build things and was really excited about the idea of problem solving and being able to build things to solve those problems. I think I started in some advanced math classes in the elementary school era. My mother was a medical secretary for liver transplant services here at Mayo Clinic. And she also was an editor of medical journal articles and probably wrote many of those articles at the time as well. And she was very supportive of me kind of expanding my mind and being able to recognize and be proud of the fact that as a young girl, I was doing well in those math and science courses.
Were you kind of the only girl or kind of like small cohort of girls kind of doing a lot of these math classes, or what was there what was the community like at the time?
Yeah, what was the community like? So starting in middle school, for sure, I was placed in at least 1 year ahead. So I think it starts with pre-algebra and then algebra and geometry and pre-calc and all those things. I do remember being surrounded by other young women, and a lot of them were in some of the extracurriculars that I was into. So I wouldn't say that it was a boys' club back then. Uh-huh. It definitely had a female presence in those courses in middle school and high school. So I think that showed how well our school district helped support all kinds of people that were showing, an aptitude for the maths and the sciences. Now, being a native from Rochester means that Mayo Clinic was always kind of prevalent in our lives. The city of Rochester, Minnesota is dubbed Med City. So many folks, parents were working at Mayo Clinic in some fashion or another. And so we generally have a high focus on the sciences and math and medicine. That said, I knew from a young age that I wasn't necessarily cut out for a physician lifestyle. It wasn't as exciting to me as the idea of solving problems and building tools. And when I was in ninth grade honors biology class, this is year 2000, we had a biomedical engineer come to visit our biology class and talk about what that is. And it was the first time that I had heard the term biomedical engineer. And so I was in ninth grade, always being, supported for the math and science courses that I was in and doing kind of some extracurriculars and science fairs. But this was the first time that I had heard those words together. And the way that she described biomedical engineering was, she said, I build tools to help doctors. And that really struck a chord with me. I really wanted to be able to help people in my career, but I, didn't want to go the traditional path of physician or RN. And that was really the spark that lit my interest in the engineering field. Her name was April Horn, and she was a unit head in the Division of Engineering. So now 21 years later, in 2021, I became a unit head in the Division of Engineering, which is kind of shocking in that it came full circle. And I left Rochester and I traveled the world for my first job. We'll get back to that. But I ended up coming back to Mayo Clinic and working in the exact same division that she had worked in.
So what was so you hear her talk, you are like, this sounds awesome. This is like what I want to do. What did you do after that? Like, what were some of those like immediate steps? Like, did you think like,
Sure.
oh, I need to like do these classes or I need to go to this program? Like what did you do afterwards?
So I, kind of immediately came home and spoke to my mother about this visitor that we had. And she was very excited to hear about this as well. I spoke to my maternal grandfather, Dick Lagergren, who was an engineer at IBM. And he helped me kind of figure out which courses I would need to take for the remainder of my high school career to prepare me for a job or even just going to undergraduate in engineering. And so I definitely focused on like the AP physics, the AP chemistry, the AP calculus, and the harder sciences as I planned out the rest of my high school career. And at the same time, I was coming up in the dance world. So I became a ballerina with Rochester Dance Company when I was 16, and I was a principal ballerina, which was kind of neat. It meant that there were about 6 of us, and it meant that when we performed with our dance troupe, we got paid. So we could call ourselves professional ballerinas at such a young age. And that was a goal that I had had since, age 6. And I'd started dancing at age 3. Coming up through the ranks and doing ballet and jazz and tap and clogging and lyrical and modern and all the different types of dance. And I also was heavily involved in ballroom dancing. And so at age, I want to say 13, I became a competitive ballroom dancer. So I did the ballet and the ballroom dancing all throughout high school. And that kept me really focused because I had very little free time. I remember being in my, tights and leotard with my legs splayed out on the floor, leaning over doing calculus at the dance studio in between classes. And that was probably what saved me from getting too distracted, was that I had a really strong core group of female friends and young men who were in the ballroom courses with us. Who were all very focused on their academics. And so we were working hard, dancing hard. It's a lot of exercise that you get. And then in between, we were always focusing on our schoolwork. So if I hadn't had that I believe that I would have had too much freedom to explore other activities that, young people get into when they're in their teens. And I'm really grateful for everyone who was along with me on that journey, and all of my dance instructors for doing the same thing. They always taught us about commitment and making sure that our schoolwork always came first. And it was a very supportive environment, and I couldn't be more grateful for that.
Yeah, I hear that from a number of folks that I've interviewed of like staying busy sometimes makes you like laser focused on whether you're balancing coursework and a
Mhm.
sport or something else. But that's awesome.
Mhm.
And so around this time, so did you how long did you continue the dance part of your uh
Sure. Yeah, so all throughout senior year, I still danced, and well, back up a little bit. I was working on figuring out where to go to school, um, and this is in the age of the internet was new at this time, and so there wasn't a lot that you could glean from biomedical engineering programs online, and so we knew that we would need to be visiting various schools. And I had some pretty lofty goals of going to an engineering school that was nationally ranked. And more than anything, I wanted to go to a school that allowed me to get hands-on experience. So from what I was hearing from various programs is that there's a lot of theory and a lot of, write this proof and solve these problems on paper, but there were not a lot of groups in biomedical engineering that were offering hands-on experience. So benchtop testing, a lot of labs and experiments. And I didn't know exactly what that meant as a teenager, but I was lucky enough to have folks in my corner who did. And the Milwaukee School of Engineering was the undergraduate program that I ended up choosing. At the time, it was ranked, I think, seventh in the nation for that program. And biomedical engineering was relatively new at the time. I mean, it had started in the late 70s and was growing popularity. And in order to grow in popularity, it needed to grow in legitimacy. And so it needed to work, the whole field had to work toward an accreditation system. And so I learned that the biomedical engineering program at Milwaukee School of Engineering was ABET accredited. And that's a very important piece of why I chose that institution. Another important piece was that it was, far enough away to get some independence, but it was close enough where if I needed to, I could drive back for the weekend or take the train back. I took the train a lot in those years. And on top of that, I decided as a junior that I would embark in their Focus on the Possibilities program, which was a 1 week long tour and kind of experience on campus for high school students to go and attend courses and eat in the dining halls and sleep in the dorms. And I went ahead and did that program as my final decision-making effort. And I fell in love with it, fell in love with the campus, the staff that were teaching, the professors, just the overall vibe of, learning and growing, and the support structure that they seem to offer was really important to me. And that's when I decided to apply early decision to Milwaukee School of Engineering. I was fortunate enough to receive quite a bit of scholarships, academic scholarships from the institution. And so that was kind of the icing on the cake. I also applied for many other scholarships to help augment the tuition costs. And some of them were open to females only, but a lot of them were kind of just local, small $1,000, $2,000, $5,000 scholarships from local businesses or outreach groups that were focusing on supporting young people going into engineering. So from high school to college, that was my biggest focus. And how your question was, how long did you keep dancing? Unfortunately, when you start as an undergrad in your first year of engineering school, you don't have a lot of time. There was a big culture shock between the kind of classes that I was seeing, even the AP level classes that I was taking in high school, and the entry level engineering courses. So I did not do any formal dancing from that point on. And I missed it, but I was busy enough to keep myself focused. And I also wanted to make sure that I was in a position where I could work. So I worked at the college bookstore for all 4 years of my degree, and that was a lot of fun.
Do you want to share with kind of the listeners a little bit about what's kind of the combination of classes that you take as a biomedical engineer, right? I imagine there's some mechanical engineering, what sort of kind of collection of courses and topics are you studying on a day-to-day basis?
Mm-hmm. So what was unique about this program is that it was a very rigid, I don't want to say rigid because it has a negative connotation, but it was a very straightforward, laid out track where you start by taking calculus, physics, chemistry. What else? Those are like the main core classes that I took for the first year and a half or so. And then you start getting into mechanical engineering, electrical engineering, and how those two things relate to physiology. So biomedical engineering is not one of the core engineering disciplines. In my eyes, the core engineering disciplines are mechanical, electrical, and software/computer. And what biomed gives you is a lot of topics, but not a huge amount of depth. Because if you're studying mechanical engineering, electrical engineering, and physiology, you can't become completely well-versed in all of them. But you are getting a taste for things like statics and dynamics and fluid dynamics and biomechanics and mechanics of materials. And then on the electrical side, there's an entire track where you start with EE 201, which is the very entry into circuitry, and you move into microprocessors and circuitry building. And so by the end of the 4 years of coursework, you should be able to apply mechanical and electrical principles to solving problems and building tools that can be considered medical devices. And on top of that, there was a senior design program. And unlike other senior design programs, it encompassed all 4 years. So we started on our project team year 1. And I totally forgot about this, but the very first year, we had to choose a general manager of our class to organize all of the design teams and make sure that they were following, traditional design controls and device development methods. And I went ahead and applied for that position, and I was granted that general manager position. So that was a 2-year role. And so on top of that, I worked the bookstore. I did my own senior design project. I was a general manager of our class and was taking all of those courses that were kind of blowing me out of the water a little bit. One thing I like to highlight when I talk about my past is that it's easy to sugarcoat. It's easy to make everything sound like it went smoothly. It didn't. It was up and down and up and down and down again. And in my first calculus class, I didn't really apply myself to the homework. It was kind of like, I'm new in the dorm life. I'm having fun meeting people and making friends. And I had just finished AP calculus and I figured I'm fine. I don't really need to do a lot of this homework. And I went into the first quiz and I think I got like a 60%. It was terrible. And I that was the kind of kick in the butt that I needed to get myself back into academic mode. And over the course of my college career, I think I failed the first time I took dynamics, which is a step above statics in mechanical engineering. Didn't apply myself. At that time, I was then working two jobs. I worked as I started as a clerk at a law firm and kind of grew into a personal assistant role for one of the named partners. And so I was working at the law firm, working at the bookstore, focusing on more friendships and things like that and having fun at school. And during that dynamics course, it just never clicked. And so I did end up failing that class. And then the next year I retook it and learned from my mistakes and applied myself and I got a B. So, it doesn't mean that your life is over if you fail once or twice or 10 times, right? You just have to keep going and try again. And that was a lesson that I learned a lot of when I was in undergraduate school.
Awesome. And so when, shifting gears a little bit, like when did the thread of 3D printing intersect with kind of your biomedical experience?
So the senior design project that I worked on was a thyroid pressure monitor, or cricoid pressure monitor, excuse me. The cricoid bone is here in the neck, and you have to apply pressure to that bone to close the esophagus and provide access to the airway during intubation. And the amount of pressure that is applied is kind of a difficult thing to learn to do. And so what we designed was a glove that had sensors on the fingers that would sense the pressure. And then there was a control box that had LEDs. And if you were in the right range, your LEDs would shine green. If you were too high, there were yellow LEDs and red LEDs on that side. If you were too low, same thing, yellow and red. And so it was just a visual way of learning how much pressure to apply. And the very first 3D printing exposure that I had was to design an enclosure for the electronics within that control box. And Milwaukee School of Engineering had a rapid prototyping center, and it might still be called that. As we all know, rapid prototyping was what we called 3D printing before it got its sexy name of 3D printing. And so I worked with the Rapid Prototyping Center and my colleagues on my senior design team to design the enclosure that we then 3D printed in an extrusion material or an extrusion process. And I'm sure it was ABS or PLA. I don't know exactly, but it was just a black box. And it was really neat to see the idea of the enclosure come to life in our logbooks on pencil, and then translate that into a 3D model and have that 3D printed. That was really cool.
And so as you're going through, doing your senior design project, did you know what you wanted to do kind of once you left? Were you thinking, do you have a set up plan or?
Not necessarily. Undergraduate was pretty tough for me. I think some people have the benefit of things just clicking for them when they're going through new courses. And for me, that was not the case. I had to study over and over to get concepts and kind of claw my way through. Not that I didn't do well in the end. I think I had a 3.2 GPA at the very end, right? So that's decent.
Yeah, that's great.
But it was not easy. And I had worked those two jobs all throughout and probably should have just stuck to the one job, but I was learning so much about law. And my first thought was, wow, I could apply the law to device development and go into something like patent law. I didn't really know exactly what it was, except, you would see things come across your desk about new devices, and you would, determine their novelness and whether they could be patented or not. Obviously, I'm distilling it into a very small,
Yeah.
small phrase, but so I got this job at the law firm because my chemistry professor's husband was the named partner that I ended up working for. His name was Albert Solacek, and Joyce Solacek was my chemistry teacher, and she gave me a recommendation to apply for this clerkship, and I got it and started to realize that law was not an area that I wanted to pursue. I don't know if it was because I was being exposed to just the sheer volume of paperwork that the attorneys were doing, or if it was more of a culture thing for me. Um, so I knew I didn't want to go into grad school right away because I didn't have a passion about anything from a research perspective. Really, I was interested in working in industry, and so I didn't really have a plan. And then in my senior year, I decided kind of last minute to show up to the career fair, and on the site, kind of really quickly interviewed with a group called Nordic Neurolab, which is a functional MRI company out of Bergen, Norway, that has a Milwaukee headquarters for the US. And they were looking for a service and support engineer. And they called me in about 2 weeks later, and I brought my logbook from my senior level biomedical instrumentation class and showed them how I designed an EKG, electrocardiogram device from scratch, built the circuitry, and had photos of myself with the leads placed here, here, and here, and the picture of my own heartbeat on the oscilloscope. And that kind of like blew them away. So the fact that I had this hands-on experience and was able to develop a device all by myself, something that's been around for decades, but I could do it from scratch and I could do it on my own, was really what got me the job with Nordic Neurolab. And I was so relieved. It was, that was in October, November. I got the job in November, and I didn't finish school until the following May. But I started working for Nordic Neurolab part-time in February of whatever year that was. I think it was 2011. And so they flew me out to Norway for 2 weeks of training. And this is in between finals and classes and things
That's
like
awesome.
that. Yeah, it was really cool. And I was able to get a pass for the first week of our last quarter of senior year. My professors were very supportive, and so then I became a service and support engineer as my first job out of college. And what I did was I flew around to all sorts of places in Canada and the US and installed functional MRI equipment. So that would entail setting up the equipment in the MR suite and getting up into the conduits and running fiber optic cabling, and I would show up, and a lot of times the coordinator for the MRI center would be like, "Are you sure that you're the person that is supposed to be doing this?" Because
Yeah.
this is 15 years ago, and I was young and just out of school and blonde and smiley, and I said, "Yeah, no, don't worry, I've got it handled. I've been trained properly, and I'm happy to install the equipment and then train your staff on how to use it." So the functional MRI equipment, for those who don't know, is it's a set of equipment that can apply stimulus to the patient, whether it be visual, auditory, or we can collect responses via buttons from the patient, and then the software allows, with the fMRI and the MRI machine, the software allows you to see what activity is happening in the brain while the patient is being stimulated.
Got it.
So I would teach classes on how to use the equipment. I was a service and support, so I would repair equipment. Sometimes within the console or within one of the control units, the little tiny fiber optic orange cables would get bent, or kinked, and then you wouldn't have signal anymore. So I would, undo the 45 torque screws on the back of the unit. And I'm just kind of sitting in a side room next to the MR suite, working on my own, replacing fiber optic cables or whatever. Maybe a printed circuit board needed to be replaced. All of that was what I did for about 2.5 years. And the travel was constant. And I enjoyed it at first. At first, I was like, wow, I'm a business traveler. I'm going to the airport. I have my briefcase. I felt cool. And I'm traveling for work. Again, I'm quite young at this time. But then as the 2 years kind of drug on, I started to get a little bit fatigued from the travel. That said, though, my support areas were North and South America. So I got to communicate with customers from sites all over and talk to them about how they're using the equipment, what kind of research they're doing, and kind of get a feel for the culture of their site. I was at Johns Hopkins, Mass General, MD&M. I was kind of going all over to these big sites and seeing how they function as a group, getting a vibe check from them. And at the end of the 2.5 years, I started to recognize that Mayo Clinic really did have a leg up on the culture. And at the same time, I was starting to get serious with the boyfriend at the time, Peter Alexander, who's now my husband of 10 years. But he lived in Rochester and he had bought a house. And so I was thinking, like, do I stay in Milwaukee? Do I continue to travel all over and kind of burn myself out? Or is it time to look for a job at Mayo?
Yeah.
So in 2012, I made that decision to come back to Rochester, and I started working at Mayo after applying to 90 different positions.
Wow. All at Mayo?
All at Mayo.
Wow. Okay.
Yeah. Because if you're working in med devices in Rochester, there really isn't another place to work. You're really thinking of working at Mayo Clinic. And I had a bachelor's, but I didn't have a master's at the time, and I didn't have a PhD. So I was overqualified for like the healthcare technology management job, which is more of a technician role, but I was underqualified to work in a lab. I didn't have that scientist background. So eventually I got a job working in laboratory medicine in IT. So some of the skills that I had learned on the software side at Nordic Neurolab were transferable to this position that I got. And what I did was I helped build interfaces between homegrown applications and vended applications. So Mayo had software development teams that would develop their own software for very specific lab practices and procedures, but then those always had to filter in and engage with vended applications that are like the EHR.
Got it.
The electronic health record. So that's what I worked on for a couple of years. And then almost as a sign from somewhere in the universe, a job opening went live. And that was for a biomedical engineer in the Department of Radiology in their anatomic modeling unit. And so I applied to that job. With all my background, I had, little background in 3D printing. I had a solid background in radiology working for Nordic Neurolab. And then I interviewed and got that job. And so that was really the first professional work that I did in 3D printing. And you can Google Mayo Clinic Anatomic Modeling Lab or Anatomic Modeling Unit. And there is an outward facing website where you can see pictures of the different 3D printed models that we fabricated when I was there. Excuse me. And so for 6 years, I worked under Dr. Jane Matsumoto and Dr. Jonathan or Jay Morris. And I worked shoulder to shoulder with the surgeons developing 3D printed anatomic models and starting in 2016, we developed a program where we were also designing and manufacturing 3D printed surgical guides.
Amazing. And so talk about the growth in technology that you guys also kind of like that. This is around the same time that like the amount of 3D printers and materials is growing as well. So you're kind of in this like sweet spot where like all this new technology is coming in. You've got this amazing application. What was that like?
Yeah, it felt like a full-time job in and of itself to keep up with the advances in technology. And by attending shows like Rapid plus TCT or AMUG, you're able to kind of keep your finger on the pulse of what's going on. We started in the anatomic modeling unit with a single printer, and you would think you would start with something small and reasonable and easy to repair, but that was not the game plan. I think it was a grander vision. So we started with an Objet 350 Connex 2, and that had the ability to print in black and white and about 8 shades of gray as digital materials. It's a material extrusion or a material, what am I saying? Well, it's the polyjet.
Material jetting.
Right? Thank you. Material jetting printer. And polyjet was the term given to it by Stratasys. They had purchased the Objet company sometime before, and the material jetting technology is not for the faint of heart. You really have to dive into the repairs and the maintenance. The daily maintenance that we performed on that machine was incredible. I mean, we were taking heads off of rollers, we were sanding down lamp covers and things like that. And it was a full-time job to keep that printer running. And we did run it almost every single day to make 3D printed models. We ended up hiring Scott Christian, who is an incredible healthcare technology management technician, to come in and help with the maintenance. And before that, we had Dave Larson joining us, and he was a member of radiology for 30 plus years and kind of a jack of all trades. But what I'm getting at is, as the person who was responsible for sitting with the physicians and designing what is to be printed, I didn't necessarily have the time to devote to the maintenance. And that is something that you start to learn, and you can learn the hard way, especially in the corporate world. Capital equipment is so much easier to source and to get approved than people. And so we struggled, with limited personnel. That was our backlog in the very beginning. Once we had Scott on site and we really got a good rhythm with the material jetting printer, then we wanted to start printing in something that could be sterilized, something that had the capability to be biocompatible. And so we chose the Formlab system, and we started printing with Dental SG. So they had a material that was meant for the dental world that we adapted into the medical world. And the reason we chose the Formlabs was because they had the material, and the machines were much, much smaller than the material jetting machines that we had. So the vat photopolymerization technology was a brand new technology to all of us there. And we went through all sorts of training online. We flew out to Boston and did training with Formlabs. And that was our second purchase. The third purchase was a binder jetting printer from 3D Systems, the 660 Pro. And that was so fun to use because it was the first time that we could print in a photorealistic manner. So we had an Artex Space Spider 3D scanner that we would bring down to frozen section when they were taking a look at the tumor margins for things that had been resected. So for example, they would take a tumor out of the jaw, they would bring it into frozen section to test the margins, but before they cut into it, we would surface scan the tumor. And we had a little cart that we would bring down into frozen section, surface scan it really quick, as quickly as possible. And then we would bring the whole cart back up to the lab and have the images stitched together by the software, which was, it was kind of a 50-50 chance that we got all of the images. I don't know if the folks are familiar with 3D scanning, but it's not always clear if you've done a good job until after the processing. But we got pretty good at it. And then we could 3D print these tumors on the ProJet 660 in a photorealistic way, which was really, really cool. After that, we got a couple of material extrusion printers. I think we started with the S2 or S3 from Ultimaker. So that we could have our students use that for their student projects and prototyping.
Do you have a memorable project that's okay to share?
Oh my goodness. All of the students, they're so close to my heart. I really enjoyed working with all of them so much. One project that I'll name is one that was done by Amika Kamath, and it was with the help of her father, who is a hepatologist, Dr. Patrick Kamath. And what they did was they segmented the liver, and the liver is a very large organ, but it separates into 8 lobes. And so they placed almost datum planes where each of the lobes separated and then labeled them. And then we 3D printed almost like a matrix of the liver with each of the lobes labeled. And that's just one of hundreds of projects. But I thought that was really neat because it showed the education capabilities, and not just for, patient education, but for professional education in the medical field as well.
And so you've had this amazing career kind of that you shared with us. Like, what's exciting you? Like, what motivates you every day to kind of keep on going? Like, what's exciting in terms of your career, the industry? What do you look forward to every day?
Well, so I mentioned that, 2 years ago, I got this unit head position in our division of engineering, and I support the mechanical development and the applied computational engineering groups. Mechanical development, pretty straightforward, designing and manufacturing devices that have mechanical components. Applied computational engineering is our group that focuses on finite element analysis and computational flow dynamics and any kind of field-based simulation. What excites me now is that we have a project in the Division of Engineering to be ready to 3D print titanium implants that are patient matched at the point of care on demand. Right now, the field of patient matched, really patient specific implants is growing a lot. And you're seeing groups like Stryker, DePuy Synthes, J&J, Oncos. You're seeing all of these companies focus their efforts on designing and fabricating implants that are one-offs, that are just for this patient and this patient's situation. That said, it's a difficult thing to justify in terms of return on investment, because there's so much design work that has to go into one implant. There are design controls that need to be applied. There are, traditional design development and device development regulatory considerations. There are quality management system considerations. And it's all for one part that you're going to maybe print 3 of and then move on. So I think a lot of the industry executives find it a little bit difficult to justify the cost of that. And luckily here at Mayo, we're not only focused on return on investment, but we're also focused on the value that it brings to our patient care. So the core value of Mayo Clinic is that the needs of the patient come first, and it's not the needs of the financial department come first. So we were fortunate to receive a Granger grant and purchased an EOS 290, M290, and we're running titanium, aluminum, vanadium, ELI in that machine. And that is a material that can be 3D printed and implanted in a patient. So if we look back at my career in 3D printing, I started in anatomic modeling, moved into surgical guides, and now this is kind of the next logical step to take this in providing care for patients using additive technology.
Awesome. Awesome. So one last question, more of a fun question. What's a book or a source of inspiration that you've had or that's kind of you rely on in terms of guiding your career, or you've learned a lot of over the span of what you've been doing and all the experience that you've had?
Oh, that's a tough one. There are a lot of books. There are a lot of sources of inspiration. I think one thing that um, challenged me and excited me back in 2016 was working with SME, the Society of Manufacturing Engineers, and preparing to take the Additive Manufacturing Fundamentals exam, because I had started 3D printing in early 2015, but my only exposure was in material jetting at that time, like we talked about. So when I prepared to take Sheku Kamara's class to prepare for the exam, it was intimidating. You know, the body of knowledge for that exam covers all 7 major 3D printing technologies and their history, their economics, their materials, their vendors, the industry. And so that really was kind of a turning point for me in terms of understanding the industry as a whole and appreciating the breadth of technology and the way the technologies can work together in a hybrid fashion to produce various parts of different mechanical properties. So I would recommend the Additive Manufacturing Fundamentals exam for anyone who's brand new to the field but is technically inclined and interested in learning more.
Awesome. Well, thank you so much, Amy, for sharing your story. Love what you're doing, and I'm sure the audience will really take a lot away from all the lessons you've learned and kind of where you've taken your career.
Thanks, Mike. I really appreciate it.
Awesome.